name's Steve Day from Coto Technology, and I'm here today to show you the world's smallest magnetically operated switch. We're here at the MD&M West show in Anaheim, California. The switch is here. We're going to have to come in and show some close-ups, I think, for you to actually see the switch. What I have here is a blown-up model of the switch. This is a magnetically operated reed switch, which is used to close an electric circuit. The way we make this switch is we build it using semiconductor fabrication techniques, rather like a semiconductor chip. The switch looks like this. We've got a metal block on a ceramic wafer. We make about 10,000 of these switches on one wafer. There's an actual electrical gap here. When a magnet comes close to the switch, that gap closes and an electric current flows between this block and this block here. In order to make a large number of these switches, we make two ceramic wafers. We build this portion, we build this portion, which is another ceramic wafer with a copper wall. We bring the two wafers together. They're sealed together with a gold bond seal, and then we dice them up just like a conventional semiconductor chip and tape and reel them, and they go off to the customer. I have two of the actual switches that I'd like to show you here with a coin for size comparison. The chips themselves are about the size of a grain of sand. They're 1 cubic millimeter. They're about 1 by 1 by 1 millimeter. They're a normal surface mount type of component, just like a chip resistor or a chip capacitor. They're applied in the same way using pick and place techniques, supplied in tape and reel. And if you look closely and compare with the pen tip, you should be able to see two of these devices shown here. Let's move to an actual demonstration of the switch itself. What I have here is a test card, and one of these switches is soldered to the tip of this circuit board here. So I bring a magnet up to the switch. When I get close enough, the switch closes under the influence of the magnetic field. Current flows through the switch. It's illuminating an LED here. And if I put this audio on, we'll also hear the audio as the switch closes. One interesting feature of this switch is that it's highly directional. If I bring a magnet in this direction, the switch closes. But if I bring a magnet in this way, there's very little response. We actually use that feature in applications where we want to reject spurious external magnetic fields so that the switch only responds to a field coming in this direction. One advantage of this type of switch for medical devices is that the switch can be operated remotely with no physical contact. If I place, I'm probably going to trash my hotel card key here, but if I put a sheet of plastic between the magnet and the switch, the magnetic field is perfectly happy to travel through the plastic and operate the switch remotely. This kind of application is used in things like in the canal hearing aids, which are now so small that they can't be operated with a mechanical switch. So a typical application is to place one or more of these switches inside the hearing aid and program the hearing aid remotely through the plastic body of the hearing aid. Another example is a capsule endoscope, which is a sealed camera that people swallow it to image the intestine. Again, those kinds of devices can be operated by one of these switches. The switch can be sealed in with the battery during manufacture, and then when the patient is ready to swallow the pill, the switch is operated, starting up the microprocessor and the video systems that pick up imaging as the pill travels through the body. So here we have it, the by far the smallest magnetically operated switch that's ever been built. I think it's got a huge amount of potential for the shrinking world of medical devices. As medical devices shrink, we're trying to keep up here and produce devices will allow them to be controlled with the advantage of zero power operation, which is a huge advantage for battery operated devices, relatively high current switching capability, and the ability to be operated remotely through plastic or non-ferrous metal barriers. Thank you.